Hello everyone, welcome back. For today's video tutorial, I'm going to have a look over a new sensor that is ADS1115, and to have a better view over this sensor, what we're going to do is to log into the website that is controleverything.com, and here we have to search on for this particular sensor, and let's see what we got for this particular sensor. And we got, it's a 16-bit 4-channel precision analog to digital converter, and you can see these are some more features which you can add for this particular sensor. Now you can also add to cart. You can purchase this sensor from this website from here. I will be interfacing the sensor ADS1115 with a particle photon, and a particle code is required for that. And to get that code, go to the source tab, and here comes the particle code sample, as you can see on my screen, and you can download the code as a zip file from here. Also, you can have the code from github.com, and you can download it from the repository that is Control Everything Community. Well, now we need to put some hardware connection setup together, and let's see how we got that. Well, coming to the hardware connection setup part, the first thing we require, which you are able to see on my screen, is a particle photon. Now this here is an I2C Shield. It's available and can be purchased from the website controleverything.com, and the reason we are using this shield is to make connections easier with other I2C devices. So for that, what we require is to gently place this particle photon over the I2C shield and make a connection just like that. Now to power up this particle photon, what do we require is a micro USB cable, which you can see on my screen, and gently insert it over this power jack. Now what do we require is our sensor, that is ADS1115, and this here is a connecting cable. Now make the connection among the sensor and the cable, and make sure that the brown wire of the cable should be connected to the ground terminal of the sensor, and same rule has to be applied to the I2C shield. So we are done with all the connections we need. Now what do we require is to have a look over the code. Now coming to the interfacing part, the first step is to log into github.com, and here we have to search on for the repository that is Control Everything Community. After clicking over here, we have to search on for the sensor that is ADS1115, and here it is. It's analog to digital converter, and this is the particle code. Let's have a look over the instructions we need to follow first. And as you can see, we have to first of all log into a particle photon and set up the device, and the steps are on this link, which as you can see I just opened, and here are some of the instructions to follow. Please do it carefully. After that, we have to download or get full the code, and we have to copy the code on the online IDE, and here comes this link, build.particle, which is the online ID where we have to create a new file, and here we have to paste the entire code and save it. And the last step, but not the least, we have to verify and flash the code on the particle photon, and the code output will be displayed in the form of logs at dashboard, and dashboard.particle.io user logs is the link where we have our relevant data. So this is how the code will have. Now after that, we will have to get back, as you can see on the particle code, and it's a .ino extension file. And in the code, you notice first of all we have included application.h and spark wiring I2C.h libraries and header files, and we have defined the address of the sensor, that is 0x48. Then we have initialized an integer, that is raw ADC equal to 0. And the void setup function, we have set some variables which you clearly see, and we have initialized I2C communication as master and serial communication with the baud rate equal to 9600. Now in the writing section part, first of all we are going to select the configuration register, that is 0x01, and we are going to send the command. And as you can see in the command, we are going to set two ends, once the positive, that is AIN0, and one negative, that is AIN1, and the voltage range is plus minus 2.048, which comprises for 0x84, and continuous conversion mode with 128 SPS, that is 0x83. It comprises of 16-bit data we are going to send as a command onto the configuration register. Then in the void loop function, we are going to read data back from the register, and it is 0x00, which you see, and from this very register we are going to request and read 2 bytes of the data, that is raw ADC, MSB and LSB, and the reading data is then converted using some of the guidelines and the formulas provided for the datasheet ADS1115. At the bottom of our code, we have the output data to be displayed onto the dashboard, which as you can see is the digital value of analog input, which exactly in a layman language is the raw value. So this is how the code looks like of the particle photon for this sensor ADS1115. Now let's have a look over the practicality of this code, the working. Now let's have a look over the working part, and for that we have to copy the entire code, and then we have to open up the terminal for the build, and here we have to create a new file as the name ADS1115 for the reference name, and then we have to paste the entire code, and then we have to save it. And after that we have to verify and compile the code, and it's verified, which is a great work. And then we have to flash the code, and while flashing the code we have to check for the magenta flash, and just now we have seen the magenta flash onto the screen and it's a successful notification, it's here. Now we have to check for the output, and for that we have to open up the terminal, the link that is dashboard user logs, and here we can have the output onto the screen, which you see as the digital value of analog input. It's the raw value. As you can see, it's 0, which means there is nothing connected among the terminals for the channel 1 and channel 0, which we have mentioned into the code. But instead, when I imply a sense battery, a AA battery of 1.5 volt, and connect it to the terminals of the channel 1 and channel 0, you can have the raw values, which is 14,580 or 90s. It's almost coming constant because we have connected a battery and there is nothing really changes exactly in a large amount. So this is how the sensor responds. Now the next step is to have a look over the features, benefits, and somehow some prominent applications of this particular sensor. The ADS1115 is a precision analog to digital converter with 16-bit of resolution offered, and is designed with precision, power, and ease of implementation in mind. The ADS1115 feature an onboard reference and oscillator. Data are transferred via an I2C compatible serial interface. 4 I2C slave addresses can be selected. Due to these prominent features, it is useful in a lot of applications like portable instrumentation, consumer goods, battery monitoring, factory automation and process controls, and a lot more. Well, you can have this sensor and you can purchase it from controleverything.com, and you can get the code from resource tab. From this site, you can download the code as zip file. Also, you can get the code from github.com, and the repository there is Control Everything Community. In the end, I would like to make it clear that if you have any doubt regarding any part of this sensor or video, you can have your queries on controleverything.com, and you can post your comments on the community page on this website. For articles and blogs, you can have a look over on instructables.com, and to subscribe more video tutorials like this, you can have a look over our YouTube channel. In the end, I hope you enjoyed this video and had a good one yourself. Thanks a lot for watching.